you actually see the y value here. And again, y is sales, x is space. And this equation came from the regression analysis down here. And it looks like Megastat did a little bit of rounding for us, but that's probably okay. Important parts, look at the f-test. The f-test is used to test the significance of the linear regression model. The larger the f-value is, the stronger the linear regression relationship is between the two variables. And here the p-value is 0.0002, which is far below 0.05, 0.10, our usual alpha values. And what that is saying is that there is sufficient statistical evidence that there is a positive linear relationship between the two of these. If the coefficients were negative on space, then you could say there's a negative linear relationship between the two. But with this small p-value, that's sufficient to tell us that there is this significant relationship. And that tells us that this formula may be actually worth using. The second question is calculate r and r squared and interpret. The r squared value, 0.764, which also shows up on your r squared as your, also shows up in the scatter plot as r squared. This tells you the proportion of total variation in the observed values that is explained by the simple linear regression model. So we have essentially 76% of the variation is explained by this model and this formula, which is a pretty decent percentage. R, 0.874, is the correlation coefficient, and it measures the strength of the linear relationship between the variables. The closer this is to 1, the better the positive linear relationship is. The closer this is to -1, the stronger the negative linear relationship is. And here with an R of 0.87, again, that's a pretty high percentage. The next question is what percentage of the total variation of weekly sales is explained by the single predictor space? That comes right back to your R squared. So 76.4% of the total variation of weekly sales is explained by the predictor space. Now what we like to happen is we like to see really high R squareds and R values and really low P values. That would mean that our data really follows a linear relationship very, very well. Sometimes your R and R squared can get a little bit low, but you still have a good relationship. But that'll usually show up in the multiple linear regression, which we'll do in the next chapter.